All right, this video is on simplifying rational expressions. And what I have here are the 5 steps that we'll be taking. And the first step and the 5th step are pretty easy. We don't need a lot of detail there. But the middle 3 steps have some information that I've kind of added here so that you can think through the steps if you need to. Simplifying rational expressions is foundational to this unit because everything else that we do in the unit ends with this step. So we're going to learn how to multiply and divide rational expressions. And when we multiply and divide, we're going to simplify them. And then we're going to learn how to add and subtract rational expressions. And after we're done adding and subtracting, we're going to simplify them. And then we're going to learn how to work with complex fractions. And when we're done, we're going to simplify them. And so throughout the entire unit, we're going to be simplifying rational expressions. So this is really foundational. All right, so we're going to start. I've got all the notes here. We're not going to do all of the examples today. We're just going to go ahead and get started with them. So the first step is to write the problem as a numerator over a denominator, then to write all the terms in descending order. So they could be mixed up. We want to make sure that the exponents start with the highest and then go down from there. Next, we want to factor the entire numerator and factor the entire denominator. I've written some helpful hints here, the different types of factoring, what to do if you start with a negative. Then what we're going to do is reduce the common factors. So we're going to cancel out factors in the top and factors in the bottom that are the same. And then at the very end, we're going to have the simplified form and we're going to be finished. All right, so here is the first example. We have a monomial over a monomial. It means that we have one term over one term. It's written as a numerator over a denominator, so step 1 is done. There's no such thing as descending order here because it's just one term over one term. No such thing as factored form for this one because, it's just written as one term over one term, so it's not factoring as far as difference of squares or trinomial or whatever. So for this one, when we reduce common factors, we're going to think of reducing fractions. 18 over 24, what number could we factor out of that, or what number could we divide out of that? So if we think about 18 over 24, both of those are divisible by 6. 18 divided by 6 is 3. 24 divided by 6 is 4. So we know that on the top, we're going to end up with a 3. On the bottom, we're going to end up with a 4. Then we look at the top. We have x to the third. On the bottom, we have x to the second. So on the top, I've got x to the third. On the bottom, I have x to the second. And I can think about what cancels out there. X to the third, x to the second. So we have an x canceling and x canceling. So here I can think about 2 of the x's on the bottom cancel with 2 of the x's on the top, and they leave 1 behind. So my final answer is 3x on the top and a 4 on the bottom, and I'm finished. So those problems are pretty simple. All right, let's go ahead and look at the next problem. Here's another example. All right, so this one, step 1, it's written as numerator over denominator. Step 2, descending order doesn't really make sense for this one because it is already written in step 3. It is already written in the factored form. So step 4 is to reduce the common factors. So let's look at the information that's written here. Reduce GCFs. So our GCFs are 7x and 3x, so we can reduce the x's at least. Those are the same. We can't reduce the 7 and the 3. Those numbers are different. All right, and then it says reduce pairs of parentheses. So we have a parenthesis that's an x minus 1, a parenthesis that's x minus 2. Those are not the same. They can't be reduced. So we can do nothing with that. And then it says if the entire numerator or denominator reduces, then write a 1 in its place. We didn't get rid of the entire numerator, we didn't get rid of the entire denominator, so we're going to leave it as it is, which means that our final answer, we've got it. We're done with that. So we have a 7 left over on top, we have an x minus 1 left over, we have a 3 left over on the bottom, and an x minus 2 left over. Now, I know I have some stuff here that I left that I haven't written about yet, and we are going to talk about excluded values, but we're not going to do it until we discuss this in class and we've completely done all the examples. Then we'll go back and we'll talk about excluded values. All right, let's go to example 3. So example 3 actually addresses step 1. So when you look at step 1, it says we have to write the problem as numerator over denominator. This is a trinomial, 3 terms, divided by a trinomial, another 3 terms. It is not written as a fraction. So we're going to write this as a rational expression. Let's go back up to the top here. A rational expression is a fraction. In math, rational just means fraction. So we're going to take this division problem, we're going to write it like a fraction, so we're doing step 1. X squared plus 9x plus 20 over x squared plus 13x plus 40. Right. Next step says write the pieces in descending order. So x squared, 9x, 20, that's in descending order. X squared, 13x, 40, that's in descending order. Now, a lot of students want to start canceling. They want to cancel this out, and you cannot. That is step 4. We're not to step 4 yet. We're on step 3, which is to factor. So when we do these problems, if you have not factored a bunch in the problem, you've probably gotten it wrong. So we need to factor the problem. For the top, we're going to look for 2 numbers that multiply to 20 but add to 9. So 2 numbers that multiply to 20 but add to 9 are 5 and 4. So in the numerator, when we factor that, we get x plus 5, x plus 4. All right, and then in the denominator, we're looking for 2 numbers that multiply to 40 but add to 13. And those 2 numbers are 8 and 5. So x plus 8, x plus 5. Okay. So step 4 says to reduce the common factors. So we can reduce GCFs, except this problem has no GCFs. So then we can reduce pairs of parentheses. So the x plus 5 and the x plus 5, those are identical, so I can reduce them. The x plus 8 and the x plus 4, I notice 8 and 4 have a relationship, but x plus 8 and x plus 4 are not identical, so they can't cancel. They can't even reduce. They have to stay exactly the way they look right now, which means that this is my final answer. It's my simplified form. So I'm going to say the final answer for this problem is x plus 4 on the top, x plus 8 on the bottom, and I am finished with that problem. All right, let's go ahead and do one more. I'm going to hold it like this so I can kind of refer to this while we do it. So depending on how you printed it, you might be able to do this too. All right, so again, we have to do step 1. So we're going to write this as a numerator over a denominator. So I've got negative 6x plus x to the 3rd divided by x squared plus x. Next, I have to do step 2. I have to write it in descending order. The numerator is not written correctly. It is not written in descending order. So if I switch the order around, I have to keep the sign with the term. The x to the 3rd is positive, so I need to keep the x to the 3rd positive. The 6x is negative, so I need to keep it negative. The denominator was fine, so I'm going to go ahead and leave that. All right, now step 3, remember I can't cancel anything. I can't start crossing out x's, even though it feels like I should be able to and I want to, I cannot. I have to factor. Now, when I factor this, these are binomials. So this is not where I draw the x and I look for what multiplies to something and what adds to something. If I'm going to factor this, this is probably a GCF problem or a difference of squares problem. And when I look at this, I can see it's not difference of squares. I don't have any perfect squares here. So this is a GCF problem. I see an x in both terms, so I'm going to take an x out. And that leaves me with x squared minus 6 on the top. And when I take an x out down here, I take an x out, that leaves me with x plus 1. All right, so I factored the top. When I look here, x squared minus 6, it almost looks like difference of squares now. If it had been like x squared minus 9, that would have been difference of squares. X squared minus 6, that's not. And then x plus 1, I can't do anything with that. So now I'm on step 4, reduce GCFs. I can see that the x and the x are the GCFs. Those do reduce. They're exactly the same, so they cancel. Reduce pairs of parentheses. I've got a pair of parentheses, but they are not identical, so they do not reduce. And so I'm going to say that's my final answer. X squared minus 6 over x plus 1. So do not worry about the rest of the notes. We will finish those in class.